So growing up, I knew that life would throw lots of challenges at me, but never ever I thought that I'll be giving a talk right after Jeff. So, um, but in a way, it's also very appropriate because the type of work that I'm going to talk about is in fact inspired by him to kind of pursue. So all the amazing advances that Jeff already talked about. So I will be looking at how we can make that more available for speakers of different languages, how we can make them more inclusive, and not just for people who know a handful of languages. So this again is a work done with lots and lots of colleagues, both at Google and elsewhere. I'm sure I have missed out many also from here. So let's get started. And I would like you to meet Sharmila, whom I happen to know for many years now. So she's 45 years old. She didn't get a chance to have formal schooling. She speaks Santali and Assamese. She has a smartphone. She uses YouTube, WhatsApp, Google Pay out of hundreds of apps that are there on the phone. But the question is, all of the advances that we are experiencing, which is available for, if you know English or a handful of other languages, is not available to people like Sharmila and hundreds of millions like her, right? So the question is, how can AI and LLMs help someone like Sharmila and many, many others like her? And the work that I'm going to present is kind of like a sampling of various types of things in this direction that we are pursuing, and is by no means comprehensive or exhaustive. So this is how the language landscape in the world looks like now. So there are about 7,000 plus languages. So there are 3,000 plus which have a writing script. For around 900 to 1,000, we have digital input keywords, like say through Google keyboards. And then for few dozens of these languages is where we have language technologies. Maybe Google Translate is kind of highest, if around 130 languages or so. But mostly if you take speech recognition, synthesis, all of that combined, we have dozens of languages out of 7,000 where these are usable technologies are available, right? Okay, so when I think about LLMs, AI, and the global south, so the notion of yin and yang comes to my mind, right? So left as is, I feel that LLMs are going to increase the digital divide that's there in the society. So people who know, say, English or a handful of other languages, where these models work well, the capabilities that you could kind of have with them. For example, maybe the LLMs can help you reformat your resume better, which allows you to get a better job. But then if you don't know, if you're a speaker of, say, Santali or Assamese, that facility will not be available to you. So that, very explicitly, that gap is going to increase. But at the same time, I feel that, I have been working on NLP for the last 20 plus years. I feel that LLMs are also best tools that are there at our disposal with the right amount of adaptations, which can help us bridge this digital divide. So that's kind of is exciting and kind of encouraging me to do more work in this particular area. So at Google, we have this 1,000 languages moonshot, where we are interested in developing language technologies for 1,000 spoken languages around the world, right? And again, this is a vision that was started by Jeff, and a lot of the work that I'm going to talk about is going to follow this. So for today's talk, I'm going to take inspiration from India, given that we are here. A lot of the language-related issues that have been motivating so far is present all around us. But the idea will be whatever we do here is hopefully more broadly applicable to other geographies which have similar characteristics, which are multilingual in nature, where the data sparsity is there. So let me kind of give you an overview about the India internet and the language complexity seen here, just so that you have a better appreciation. So thanks to improvements in connectivity, availability of smartphones, we have a growing number of people who are connected to the internet, right? So, and the number from October last year is that we have about 890 million people who have internet subscription, uh, only about 10% of the population knows English. So this is from the 2011 census, which is the recent census that we have. And then through multiple surveys, it has been realized that there is strong appetite in consuming the web and benefiting from the internet in a language of their choice, which is different from English, right? So that way the appetite and the need is there. It's just that we don't have the right technologies right now to serve in those languages of choice. So the language landscape in India is also complex. What I have shown you here is again from the 2011 census. So we have 22 scheduled languages, so which are languages which are recognized in the Constitution, plus English, so total 23. And how many native speakers or people who recognize these languages as mother tongue are listed. So I mean, Hindi, you can kind of see that this is a dominant language. But then again, Hindi, we think of Hindi as like a one single monolithic language, but that's not the case, right? So if you look at the variations, dialects, there are 40 plus different languages which together are clubbed under this Hindi bucket. Yeah, and then total we have 1,300 plus languages. We have 60 plus languages which have at least million or more number of speakers, and around 125 languages which are 100,000 plus speakers each. Total 1.3 billion population, that's probably is around 1.4 now. And then we are also a multilingual society where people know multiple languages and we end up using those languages even in a span of a single sentence or a paragraph, right? Which adds additional complexity through problems like code mixing, which is mixing of all of these different languages. So if you look at where does some capabilities even within the research community lies, so that would be restricted to these top 10 languages or so, right? So, but then again, there is also a gradation of quality across these languages. And then if you go beyond these top 10, even within these 22 languages, so there are about 127 million speakers whom we are not serving at all in a language of their choice. And this number is 5 times the total population of all Scandinavian countries put together, right? So this kind of gives you a feel of a sense of how many users are still unserved. And one of the main reasons, why we are not able to make enough progress on this in all of these languages is data is a problem. So right now the recipe that we have is that if you have data, we have we know how to build models around that. And just to give you some idea, and using Wikipedia, number of Wikipedia articles as a proxy for availability of data in these languages on the net. So for English, there are about 6.6 million articles. That number for Hindi is about 160,000, right? And then if you look at languages like Oriya, so we have maybe a few tens of thousand, 10, 20,000 documents on Wikipedia, and that's a language spoken by a few tens of millions of speakers, right? So there is a big data skew here. So so now I'll kind of hopefully this kind of motivates that there is a great need. I'm motivating from India, but the need is kind of global, and then data sparsity is one of the big problems. So you cannot be building one language or one capability at a time, right? So thanks to advances in large language models or language modeling and multilingual versions of that, I feel that we now have a true opportunity to kind of scale these models. So, so we have been working on language modeling even before large came in. So we were kind of I guess hipsters in language modeling that way, I guess, before it became cool. And then initially we started off with these masked language models where given just sentences from the web, you can mask certain words, and then you can ask your language model to make prediction here, right? So and then since you know which words you mask, you could you could calculate the loss and then use that loss to update the parameters of your language model, right? So these kind of masking strategies were used in the BERT style models, to update the parameters. So it turns out that if you just use that same idea and then just apply that on multilingual corpus, right? So you have like corpus from different languages. So surprisingly, these models are able to learn some sort of like a bridge representation, which allows you to map like all of these different language data into one common representation, which allows you to do transfer of knowledge and supervision. So we did this in the context of Indian languages and built a model called Mural, which stands for Multilingual Representations for Indic Languages, which at the time of its, and we also open source this. And at that time, so this is around late 2020, early 2021. It also had support for like a native script and transliterated text. So this is like a Romanized version, which is a very common thing to do because input otherwise on the keyboards are difficult. And then through a varieties of like benchmark tasks, we found that building these kind of region specific models are helpful, and they give you like improvement in performance, right? So again, now if you have some like language understanding problems for Indic languages, then building on some model like say Mural could be a good starting point, and you can fine tune and do adaptations for your task. For certain things so these are the two evaluations. So this is on the native script and this is on transliterated data. But in this case, compared to other state-of-the-art models at that time, we saw considerable improvement in performance. And one of the reasons was that this MBERT model didn't have exposure to the transliterated or Romanized data, which again, if you pay attention to kind of the local nuances and the needs that are there, you could look at improving performance. So we also used Mural to improve the query understanding capabilities in Google Assistant. So query understanding is the problem when you say okay, set an alarm for 8 a.m. You need to know that there is an alarm setting intent. You need to know what time you want to set the alarm. So that problem is called semantic parsing. So we built a single semantic parser model for 8 Indic languages, which was built on top of the Mural model, and that has been launched. And what we found was that for more complicated queries, if you say things like I do not want to set an alarm at 7 o'clock, but I want to set an alarm for 8 in the morning, right? So now you're able to, the model is able to parse it better because there are two times that are mentioned here, so it could become confusing, right? So the point here is that by building these kind of multilingual language models, you could improve products for which directly impacts users, right? And kind of bridge the gap between research and real-world deployments. So in the subsequent to that, in our next evolution of language modeling, even focused on Indic languages. So Mural had coverage for 17. So now we are looking at scaling that to 100+ languages as part of the language inclusivity moonshot. And while we started off with text, now we are also looking at multimodal of also including speech in addition to text. So in the rest of the talk, I want to give you a sampling of different efforts that we have been undertaking to make this transition and build models, speech text models for 100+ Indic languages. And I have divided the work along 3 buckets, right? So one is the inclusiveness bucket, so where we need more representative data. So we have an effort called Vani, which is trying to capture the speech landscape of India. Second one is around composition. So should we be building one monolithic model that covers all of these different languages, or could we have more modular structure to kind of build across these different languages? We should be paying attention to responsible AI. We want to make sure that these models are safe. So we have an effort around Bindi. And then finally, something around how we can make phones more helpful for users as as the last mile. So we have an effort called UGIF. So I'll touch upon that towards the end. So first, the Vani project. So this is around the theme of representative data. So where we are interested in how we can kind of get speech data, which is truly representative of India, right? So here we're interested in capturing the speech landscape in the country. So the point about spoken language is that even for a single language, like, where it's spoken matters, like, how it's spoken. For example, like, if you take, like, say, Kannada, the way Kannada is spoken, say, near Mysore is going to be different from, say, northern Karnataka, where, like, there are influence of other languages in that region, right? So the point here is that, like, rather than anchoring on the identity of the language, maybe the diversity is there on the ground, so let's anchor on the region. So we are taking a region-anchored approach. So just to drive home this point, I want to play a quick audio clip here, which shows that, like, when you take a sentence and ask it to be spoken in the different parts, right? So how that varies. So we took a sentence called, like, how do you go to Pragati Maidan? And in the UP Bihar region, which is the northern part of the country, we ask people to say that sentence in the way they would like, and just take a listen to the variations. So that's the idea of, like, doing like a region-anchored collection rather than language-anchored collection. And this is in collaboration with Indian Institute of Science. So if you go to vani.isc.ac.in, you'll be able to, like, see some samples of the data. So the project is moving in phases, and we are close to phase 1 completion. And our unit of operation is at the district level. And what we do, by the way, is that like, in each district, we collect locally relevant images, show it to people, and then ask them to describe in a language of their choice. So whatever language they would use at home, we ask them to describe in that particular language. And then 10% of that speech data is being transcribed, again, at a district level. And then all of that data is being open source, right? So this is like, an effort to also help the ecosystem so that, like, others can also build on top of these models. So this is the phase. So right now we are closing phase 1, which is 80 districts, and starting phase 2 in 80. So after phase 2, we would have covered all the states in the country, right? And at least one district in each one of those states. And what you see on this plot here, here is the different regions where we have been active in phase 1, right? And the colors in these circles are representing different languages that people have spoken when we ask them to do. But one, like, that has been really kind of like, gratifying to see is that when you ask people and give them the choice to be like, to express themselves in whatever language they want, the diversity of languages that people use is tremendous, right? So we have seen people use languages like, Chhattisgarhi, Angika, Magahi, like, I mean, languages, like, we have seen people use even like endangered tribal languages, right? So none of those would have been on our radar if we were, like, being prescriptive upfront, saying that, like, speak only in these, like, 10 languages, right? So that has been really great to see. That's where, like, the end users' expectations are, and we should be meeting them where they are, rather than kind of like, being prescriptive and being forced to use a subset of languages that we care about. Okay, so that's about representative data. Please do check out vani.isc.ac.in for continual progress and release of data here. Now, the second one is around, like, moving to composition. And here the question is, like, right now the status is that if you want to use an LLM and then like, want to adapt it to a new domain, then you have to do some sort of, like, fine tuning for data from that particular domain, or maybe continued pre-training, which could become expensive if you are, like, working with large models. So our effort in CALM has been to see whether we can develop more composable strategies to do this kind of training, right? So let's say that, like, we are interested in enabling the model to do some sort of key value, some arithmetic over key values, right? So things like, what is the value of x1 plus x8 times xn, right? So what we do is that we have, like, two models. So one is like maybe a relatively larger model, which is capable of doing arithmetic reasoning, numeric arithmetic. And then we have another augmenting model. So we call this one as the anchor model. And we have an augmenting model which has knowledge about this key to value mapping, right? What is x1, what is x5, and so on and so forth. Now, in order to answer this particular question, like, you will recognize that you need capabilities or skills of both of these two models, right? So one needs to provide the key value mapping, other one needs to do the reasoning. So what we do is that we keep both of these two models frozen, so we don't change their parameters. But then we have like set of cross attention or like some glue parameters, additional parameters to align the representations that's there in these two models, right? And then we do a little bit of continued training for this particular model to get like the final result using some sort of maybe like chain of thought type of explanation of how they arrived at that particular answer, right? Okay, so this kind of like now opens up a more flexible way of development, because now I could have like a core anchor model, and now like different skills that are being added by other augmenting models, right? So we applied this framework for the language inclusion case, where we took again like an anchor model, which is the PaLM2 S size model, and then also had like an augmenting model, which has knowledge about additional languages that anchor model didn't know, right? And then we trained this CALM compose model, and then applied this for machine translation problem from those target languages, low resource languages, to English, right? So when we do that, we do see that this compose model is able to get improvements in performance compared to that anchor model in itself, right? And interestingly, these gains tend to be larger for the low resource languages compared to the high resource ones, right? Because this model was already like maybe had more expertise in those high resource languages. Now with the additional knowledge that's coming in from this augmenting model, now we are able to compose them. Now this is an early demonstration, but it also gives some ideas that maybe different communities could work on developing this kind of augmenting model, and then we can have a more flexible and participatory way of building these kind of models together. Okay, then some other pieces of work on Jeff mentioned about the data quality is important during pre-training. So one of this work in presence, we have like a model-driven way of selecting or weighing instances during pre-training, which seems to kind of result in better pre-trained model quality. And then when you're working with say speech data, you want to augment your model with, say if you have a large speech corpus, you want to augment data from a particular language to maybe do the balancing. So doing language identification on that speech data is important. So we have a model called Musli, which basically uses multimodal signals to improve language identification capabilities for speech and text. Okay, so that's so much about inclusiveness, about data and some modeling ideas. Now let's move to how we can ensure that these models are responsible, but also in a contextualized manner. So what do I mean by that? So please note that some of the examples that I may use in this part of the presentation might be offensive to some of you. So this is the problem of recontextualizing fairness in NLP. So this is motivated by some work done by Sambasivan et al., which made the observation that fairness work in AI and particularly in NLP have while whatever little amount of work has happened, that has happened within Western lens, right? So maybe they have looked at things from an Western values perspective, norms and all of that. But when you are developing these models and then that get used throughout the world, it's important that these are also adapted to the target geographies, cultures, and languages. Just to give you an idea, if you look at say US and India, so there are shared axis of discrimination between these two regions, right? So for example, say gender and religion will be that shared axis, but then in India, we also have caste and regionality as an additional axis of discrimination. So you want to make sure that your models have been tested and mitigated for those kind of biases. And these are also not some abstract problem. So we actually, if you look at existing, even specialized models, you do see these kind of problems. So we tried to evaluate this for sentiment analysis models, which are off the shelf that are available. And what we did was we had a few templated sentences, right? So where you have an identity and then people love food. So let's say that's a sentence. And then you put different identities here, say Gujaratis, Bengalis. So these are different regional identities from India. So we did this experiment involving regionality, caste identities, and religion identities, right? And then just in these templated sentences, put this identities and apply this off-the-shelf sentiment analysis models, which given a piece of text will tell you whether it's positive or negative, right? So ideally, just by changing these identities, the sentiment scores should not be changing, right? That's the expectation. But you see that when you apply these different types of identities, be it regional, caste, or religion-based ones, there is big differences across them, right? So, so this is to demonstrate the point that we have work to do here to even though we use kind of this standard sentiment model from Hugging Face, there are kind of issues to be done, handled. So, so realizing this, we laid out a research agenda in this AACL 2022 paper, which is looking at societal context and technological gaps and value alignment to organize and give some structure to go forward with research in this particular area. So a specific type of evaluations that I want to talk about is on stereotypes, which is broad generalizations about a group, and some of that may be true, but most of the times it's not. So it's important that so if you want to evaluate whether a stereotype, your model is generating some negative stereotype about a particular entity, it's important that we have representative evaluation data sets for that, right? So turns out that when we started looking at this problem, we didn't have broad coverage stereotype data sets of say identities and stereotypical attributes together, and this is how the map looked like. At least even looking at different geographies, and vast parts of the world were not covered in any of these existing stereotype data sets. So we developed a method and data set called Seagull, which used again the knowledge within LLMs to kind of increase a larger set of candidate identity attribute stereotypes, which were then subsequently vetted by humans to determine whether those are actually stereotypes or not. So in the interest of time, I'm not going into the details of how we did this, but this is what the final outcome looked like, right? So this was how the coverage map looked like before, and after doing this is much more greener. And then many of the regions that were not covered earlier, those are also covered now, and ultimately we had 7,005 stereotypes covering 178 countries. So this is all available from this URL and the QR code. So you can if you want to evaluate your model, you can download and evaluate it against this. So one other thing is that this need for recontextualization and this targeting towards different geographies and cultures is important. So what we realized here is that if you take these annotators, whether they are from that particular region from outside, they end up suggesting different types of stereotypes, right? So in this particular case, so if you take in Australia, and then the set of stereotypes that we have for identities from Australia. So for certain number of those stereotypes, there is overlap between the stereotypes that are given by annotators from outside the region, and then annotators which are from that particular region, right? But then there is a disjoint set that's not covered by each one of them. So who kind of evaluates that your who is looking at this problem, right, can also matter. And there is need not be one universal goal truth all across. So the first part is about how we can use LLMs to scale up these stereotypes, but then LLMs can only cover so much, because not all of our societies problems are reflected on the web, and maybe the data set is not going to be captured in LLM. So it's also important that we also directly engage with communities who are being who have been victims of say discrimination in the past, and so that we also can capture those additional dimensions of stereotypes and other types of harm. So that's where we have an effort called SPICE, where we did this kind of direct community engagement to source these kind of stereotypes directly from the communities. So I will not go into the method details, but just give you some idea. So one thing is that we are able to capture more finer grain and intersectional identities. I mean, you may have Dalits as a caste and a woman as a gendered identity separately, but Dalit woman is an intersectional identity, right? And that kind of can maybe like, subjected to even like, higher levels of discrimination if you have these intersectional identities. Then we also saw things that are like, complementary and new, which were not covered by that LLM-based approach, the Siegel one that I talked about. And then also, if like, say people outside of India think about Indians, like, maybe vegetarianism will like, come up as a stereotype, but then I think like some 75 to 80% of Indians are actually not vegetarian, right? So maybe like, Brahmins, like, are say vegetarian to a large extent, and that's what like, we kind of like covered through this kind of community-based direct engagement. So anyway, this is the complementary approach of like, looking at using LLMs, how much ever you can scale, but then also engage with direct communities. I think there is no substitute to that, but then there are also research challenges of how we can scale that up. That's a challenge. So finally, Jen, how much time do I have? 5 minutes? Okay, great. So I'll wrap it up. So finally, I'm just going to talk about like, how we can, even if we have developed all of these like, capabilities, maybe we are going to bundle them all in our phones, then how we can make that usage of the phone easier, right? So this is especially like a problem for people who are kind of like using smartphones or internet for the first time. The phone is still very complex for them. Right? So I talked about Sharmila early on. Even though hundreds of apps are there on the phone, she uses only like 3 or 4 of them, right? And like there are various like user studies which have demonstrated that these kind of like complexities affect like women particularly more. So the question is, can like you use like AI or LLMs to make these things better? So that's exactly what we did as part of this effort called UGIF, which stands for UI Grounded Instruction Following. So where the goal was that given some query, like say how to turn on data saver, right? So could we kind of like create basically this UGIF model and system creates a grounded interactive video for people to follow, right? So the goal here is not only to do things for the users, but also show them how to do it on the phone, right? So there is a tutorial aspect to this, and the system is going to basically wait for the user to do the right thing, and only then you are going into the moving to the next, right? So the point here is that if they are able to do it themselves, then like they will get more confidence and like discover more parts of the phones to do it. So how do we do it? So given a query, we go and like retrieve relevant help articles, right? So the point is that like lots of these help articles have been written already. So could we kind of like convert those help articles into executable like video tutorials on the phone, right? So that's exactly what we do. We retrieve the video article, the help articles given the query, parse out the relevant parts of those documents, convert them using language models into executable steps on the phone, and then execute them on the phone, right? And that kind of like through that you get the tutorial, like the demo that you saw before. And in order to facilitate further research in this area, we have also released a data set called like the UGIF data set that's available from this. So where you get all of these like step-by-step instructions, the query, like what is the string, what are the like the step-by-step things that need to be done, and also this is multilingual, right? There are multiple languages that like this has coverage for. And the good thing is that like while LLMs have done lots of good things, but this is where a problem where there is enough still headroom for improvement, right? So especially for like the PhD students in the audience, like so if you're looking for a problem to work on where there is like good progress to be made, this could be one, and then there is like an accompanying data set to go along with this. Okay, so I think I'll just maybe quickly parse. So yeah, we have been happy to see like recognition for our work, including this fact sheet from White House when like Prime Minister Modi visited the US last year, and then there was this communication, and we are happy to see some of our work getting like mentioned there. So since there are students here, I thought like I'll just open up like or end with some like open questions from my vantage points, and like encourage you to work on this. So I think like again, this is not like comprehensive. This is like just from whatever I can see is kind of like important. So one is like data sparsity is still a big problem, how we can make things work when you don't have enough data. So one question there is like could multimodal signals can kind of like help overcome data sparsity in one modality with like data from another. For example, if you don't have text, maybe for many of these languages, could speech data be a substitute to kind of like develop capabilities? How we can work with LLMs and develop them in a scalable and composable manner. So Jeff mentioned that he has 900 authors, right? So can we make that 100,000 authors in a paper to build these kind of models, right? So could like some of the compositional ideas that I talked about earlier, or like other variants, could we have like more flexible ways of doing that? And then finally, we should realize that like people are at the center of all of this at the end of the day, right? So we should not lose that focus. Like, and when we are building these models, what kind of harms that these models could do, and how we can involve them, like both people and communities, to recognize kind of like the issues that are there, and then like how we can mitigate them, and doing it in a more participatory manner, I think is super important. So this is, I think, like a very exciting area of research, and I'm particularly excited because there are both foundational research and the societal impact possibilities that exist. So yeah, so I'll stop here, and thanks for your attention.